அனைவருக்கும் வணக்கம். யாவரும் திருமலர் சங்கம் பெருமையுடன் நடத்தக்கூடிய வாரம் 13. நீங்கள் அறிந்ததை மற்றவருக்கும் கற்பித்தால் நீங்களும் ஆசானே. என்ன இது நிற்காதற்கு தக யாவரும் கேட்டீங்கள ஒரு புதிய படைப்பா இருக்கே. நம்மளுக்கு தெரிந்த ஒரு விஷயத்த மற்றவங்களுக்கு சொல்லித்தரதுதான் இந்த களம். நிற்காதற்கு தக இந்த வாரம் நம்மளோட நிகழ்ச்சியில பங்கேற்று இருக்காங்க ரேஷ் முகிஷா அப்படிங்கிறவங்க. அவங்க என்னத்தை பத்தி நமக்கு சொல்லி தர வராங்க. வேவ் பவர் ஸ்டேஷன். அவங்களுக்கு நம்மளோட யாவரும் கேலி திறன்வளர் சங்கத்தின் சார்பாக வாழ்த்துக்களும் பாராட்டுகளும்.
Thank you, ma'am.
All the best.
Thank you, ma'am. A warm and pleasant welcome to everyone who have gathered here. I am Resh Murisha, currently doing my undergraduate in physics from Martha Kesri Jain College for Women, Banimbadi. Now, let's get into the topic about wave power station. Before getting into the topic in detail, let's see about the contents. First, wave power, how it works, ocean wave energy technology device, and the introduction, modern technology, current technology. In current technology, we're gonna see about BUOYANT mod device, hinged contour device, oscillating water column. In oscillating water column, the subcategories are ocean wave power generation, ISLAY wave power station, and the fifth one is about potential, that is how much potential is gained by the wave power station. And the sixth one is about challenges, the challenges faced by the wave power station. And seventh is none about advantages, and the eighth is none about disadvantages, and the ninth one is about the conclusion. Now let's get into the topic in detail. Wave, it's actually nothing but a wind passing over by the sea. That is, it is generated by a wind passing over the sea. That is, it is organized form of wave. Due to disorganized turbulence, because wind pressure pushes down a wave trough and lifts up a wave crest. That is, in this diagram, we can able to see that crest and trough. The distance between the one wave to the another is known as a wavelength or a wave period. And the distance 0 to some other distance is known as amplitude. Due to Behr principle, large waves are more powerful. That is, they have discovered that the large waves are more powerful. And wave size, it is determined by the wind speed and fetch. Fetch, actually the distance over which the wind excites the wave, is known as the fetch, and by the depth and topography of the seafloor. What is topography of the seafloor? That is, which can focus or disperse the energy of a wave. And here, a given wind speed has a matching practical limit over which the time or distance will not produce a larger wave. This limit is known as a fully developed sea. Next, we're gonna see about wave power. Wave power is actually but a power drawn from waves. That is, the force coming from the wave. Due to that force, we can also collect an energy. That here wave power refers to the energy of ocean surface wave and all the capture of the energy to do useful work. That is, including electricity generation, desalination, and water pumping. That is, vapor is a form of renewable energy, though it is known as a renewable energy. Why it is known as a renewable energy? Since it can be recycled and recycled, it is known as a renewable energy. Though often commingled, wave power is distinct from the diurnal flux of tidal power. In this diagram, we can easily come to know that how they are generating a power. Then in detail, that is how it works. We cannot say we can generate an electricity from an ocean. So now we'll see about how it works. That is, in this diagram, we can see that wind blows across the sea surface. It transfers the energy into waves. How it just transfers the energy into waves? That is, it makes the water rise and fall in the chamber. So since transfers the energy to wave, they are powerful source of energy. The energy output is measured by wave speed, height, wavelength, and also by an water density. Now, in this diagram, the air is blown in and out respectively of a chamber, which makes water bob up and down, and it causes a wave. At a wave power station, the waves arriving causes the water in chamber to rise and fall, which means that air is forced in and out of the hole in top of the chamber. Here we can see that due to that air is forced in air is forced in and out due to the turbine or a generator, and electricity is produced. At a wave power, the waves arriving causes the water in chamber to rise and fall, which means that air is forced in and out through the hole to the top of the chamber and the turbine. And for it, let's see about the ocean wave energy technologies. There are variety of technologies have been proposed to capture the energy from waves. That is, due to wave technology have been designed to be installed in nearshore, offshore, and far shore, where nearshore represents the nearer to the beach. Offshore represents the middle east of the sea, where far shore represents the large kilometers or feet of a location. Here, offshore systems are situated in a deep water for generating a power, typically of more than 40 meters, that is 131 feet, while all wave energy technologies are intended to be installed at or near water surface. That is, they differ in their orientation waves with which they convert the energy of waves into other forms, usually an electricity. Here we can see that waves are actually moving one by one, but in one side it shows us as the surf zone, and in the middle side of the sea it shows us the wave height increases, and here this shows about the wave cradling. Wave cradling is nothing but the wave passing by one another. As in wave cradling, the waves slow down as water gets shallow. Shallow is nothing but it gets inside. And in wave height increases, it shows that wave energy and the decreases in water depth, where it pushes the water upwards. And in the surf zone, we can see about the back of wave moves faster than the front. The wave becomes too high and breaks the other wave. Now let's see about the what are the devices used in ocean wave energy technologies. First, the oscillating water column. Actually, the first diagram represents the oscillating water column machine, and it is actually a form of terminator in which water enters through the subsurface. That is, in this diagram, we can able to see that a wave is actually passing by through a subsurface, and it's opening into a chamber with air trapped about it. And due to that air trapped about it, the wave passing through it, it's actually captured in a chamber. And the chamber and the air compressed in the chamber is converted into a turbine or a generator. Attenuator is nothing but a long multi-segment floating structure oriented platted parallel to the direction of waves. That is, here in this diagram we can able to see about a red color thing, right? Here the red color thing represents the attenuators, which means a long segment which has 5 subdivision ends in it. It can actually generate a wave of 750 kilowatts, and it's of a length 150 meter, and it's of a diameter 3 meter. When a wave moves across to the sea and causes the thalamus to rise and fall like a snake-like motions. Here, this section move against each other on hinges resisted by an hydraulic rams, driving generator to produce an electricity. Here, a waveform would have a 40 machines over square kilometer, which actually generates a power for 200,000 homes. The here, this overtopping devices is nothing but a reservoir that are filled by incoming wave. That is, its work is actually nothing but to generate electricity when the wave comes into an part of the machine that is filled by incoming waves to levels above the average surrounding oceans. Here in this diagram, we can able to see that a wave funneled topping about a generator, and when it enters into a turbine outlet, it actually rotates into 16 into 250 kilowatt power. That is, the turbine rotates into in this power, and it actually produces a 4,000 milliwatt reservoir, which is about a 16 centimeter of a generator. Next, let's see about a modern technology. It's actually categorized by the method used to capture the energy of the wave. And it's actually categorized by a point observer, location, oscillating water column, overtopping, and mainly attenuators and also and location. Where it is categorized by location are shoreline, nearline, and offshore. And the current technologies are according to DTI. DTI is nothing but an a research center that is used to find about the waves and about a normal thing used in all over area. There are three types of wave energy collector. The first one is buoyant mode device, and the second one is hinged contour device, and the third one is oscillating water column. Let's see about these three things in detail. Buoyant mode devices. Actually, this type of devices floats on a surface of the water or below it. It is moved to the seabed by either a taut or a loose mooring system. That is, in this diagram we can see that it actually fixes its surface into a sea. That is, due to the motion of sea, it actually changes its body towards the sea. Here the duck moves up and down through the waves, and when waves approaching a duck, it actually changes its motions and form a same motion. Here, ducks work by independently rotating about a long linkage, and this maintains its stability by outspinning wave crest. The front edge of the duck matches the wave particle motion. The device requires a depth at least 80 meters and uses a system of weights and floats to give almost constant tension in mooring cables. Then let's see about contact devices. It's actually a device follows the motion of wave. It creates a power using the motion at the joints, and it's commonly moved slightly to hold it in a place. The pelamis move with wave. The motion resisted at the joint by hydraulic ramps that pump high pressure oil through hydraulic motors via smoothing accumulators. And it's in this graph, it's also been said that the 750 kilowatts device would be about a 150-meter long and 35-meter in diameter, and it comprises into a 5 section of it. Here, even in this graph, we can see about a 4 to 5 lines have been drawn in each graph. That is, it represents the each section of the devices. Mm. Next, let's see about oscillating water column. This method is actually about generating power from the tide work by using a column of water as a piston to pump air and drive a turbine to generate a power. And it's actually nothing but when a water enters into it, the rising water column occurs. When the rising water column occurs, air is blown in and out. When air is blown in and out, the through the back wall, that is impulse turbine has been fixed, right? In that impulse turbine, the air is taken inside and it forms actually a wave. Here the wave crest, which means they said about it actually causes a wave, and by causing a wave they generate electricity. Here it in renewable energy, since due to the wave that it actually occurs in a seabed and air flows into it, and due to the cement structure fixed to a seabed or installed on a shore, it enables us to take step forward, becoming self-sufficient in renewable energy. And let's see about the ocean wave power generator. A while back, a discoverer wanted a simple way to demonstrate how electricity could be generated from the up and down moment of an ocean wave. That is, how it will be generating a current that is due to a up and down wave of current. So actually, they wanted to test about it. So here they uses a simple plastic foam float which is attached to a lever arm and which is connected to a shaft of an inexpensive stepper motor. And when it's properly mounted in a tank of water, the motion of wave in the tank causes the shaft of stepper motor to move. Actually, in this diagram, we can see about a plastic foam floated foam which is basically fitted in an lever arm and with an expensive stepper motor. And with the tank of water, it causes a motion of wave. And through that motion of wave, it causes a crust and trough. Where due to that crust and trough, it actually causes an energy. That energy, due to a turbine or a generator, it's converted into an electricity. That is, it causes the shaft of a stepper motor to move. That movement produces enough electricity to turn on the visible red LED light, which is due to from this energy we can turn on an red LED light, which is high light emitting diode. Next, let's see about a ISLAY vapor station. The ISLAY vapor station provide about a 0.5 milliwatts of electricity for the ISLAY grid. ISLAY grid is nothing but the wave settings. Here in this diagram, the first one represents the wave capture chamber, which is set into a rock face, and the second one represents the nothing but the tidal power forces water into a chamber, and the third one represents the air alternatively compressed and decompressed by oscillating water column, and the fourth one represents the rushes of air drive the Wells turbine, which creates an electricity. Here in this diagram we can actually see about the first one. Here this represents the rock phase, and the blue one represents the wave power forces water to enter the chamber. That is just because we are fitting a machine into a wave, we cannot push or we cannot make a force, we cannot give a force to it, so it actually forces the water to enter the chamber. And this yellow arrow mark, which is represents the above and below, it actually compresses the air occurring on there. And the last green one represents the air drives well turbine. Then the fifth one is potential. That is how much potential that the vapor station gives about. Due to the theoretical resource potential of ocean energy, it ranges from 20,000 kilowatts to 80,000 kilowatts of electricity generating per year. That is, from wave power, we can actually collect about 20,000 kilowatts to 80,000 kilowatts of electricity for an year. which actually represents the 100 to 400 percentage of the current global demand for electricity. Here, this formula actually represents the power transmitted by a string wave. That is, what happens when a wave passes for a one. So here, the formula is to find out it of mu omega square a square b. Here, mu represents the mass per unit length of the spring, and omega represents the, as usual, angular frequency of the wave, and a represents the amplitude of the each wave, and v represents the wave propagation velocity. And what are the challenges faced by wave power station? Actually, there are some of challenges to developing wave power devices efficiently converting wave motion into an electricity. Wave power is available in an low speed, high forces, and the motion of forces is not in a single direction. That is always a wave cannot be in a single direction. It actually changes the direction, and it also changes its motion too. And the next challenge is faced by is about a constructing device where it actually faces a mini problem that can survive strong storm damages and water corrosion. Since we are placing a machine in a seabed, it actually causes a saltwater corrosion. Likely sources of failure include seized bearing, broken wells, and snapped mooring line. And the next one is high total cost of electricity. Wave power will only be competitive when the total cost of generation is reduced. These are the major challenges facing by the wave power station. And the seventh one is about the advantages. The advantages of wave power station is nothing but actually the energy renewable energy also recreate it. We cannot recreate it, just we can reuse it again and again. So energy is free. And for machines, there is no use of fuel and no waste produces, and there is no waste produced also. And it is not that expensive to operate and maintain a machine, and it can also produce a great deal of energy. That is, since it's an renewable energy, it produces a great deal of energy. This and the next is disadvantages. Disadvantages is nothing but depends on the sometimes we will get sometimes we not get anything, and sometimes we actually need a suitable site to place a wave where waves are consistently strong. We cannot say always we can get a lot of energy. Sometimes we get a lot of energy, sometimes we get okay, this energy is required at least to light or led light, but sometimes it doesn't even cost, even it gives nothing. And some wave machines and wave designs are very noisy and must be able to withstand with rough weather. And at last, the conclusion is about wave power has an important role in generating electricity. That is, it is a renewable energy. So without wasting it, without wasting, we must save the energy and we must convert that energy into an electricity. That is of energy of wind waves to do useful work. For example, it actually generates an electricity and is used for water desalination or of pumping water. Thank you. Thank you for giving me this wonderful opportunity. And I thank my management, beloved principal ma'am, and my HOD ma'am as well, and to my beloved parents also. Thank you. Thank you, ma'am.
Thank you so much. Thank you for your wonderful Thank you.